Hello, sixth graders. Welcome to your two-dimensional geometry review. So there are a lot of notes for geometry, and I would suggest that you write down some of these notes, especially on that note card that you can use. Here are some notes for what we're going to be doing, and I'm going to take a few pages where I'd like you to just pause the video and write any notes that you need, but I'm going to move on. Okay, from that other page, you learned a few things about angle pairs. But before we get to angle pairs, we're going to look at these first two angles that are just this one and this one that are just hanging out here. So I'm going to have some angle degrees, and I want you to tell me about how big is that angle. So we're measuring the space inside. I like to think of this as like it's a door. How far open is that door? Okay, one thing that we know is that we know 90 degrees makes like a perfect kind of angle. Like this would be a 90-degree angle. And so you can see that the purple line that I drew over the top of that angle is bigger than 90 degrees. So we're going to take a guess, and I'm going to give you some options. I'm going to say something like, do you think this angle is 30 degrees? Do you think it's 50 degrees? Do you think it's 115 degrees? Do you think it's 170 degrees? And you have to decide, well, based on that 90 degrees, what do you think it's closest to? And I would say this is bigger than 90, but not a lot bigger than 90. So I would say it's about 115 degrees. So you don't have to know exactly how many degrees it is, but you have to be able to circle the answer that's closest to the correct answer. This other one, well, wow, that looks like it's exactly 90 degrees. So I can say 90 degrees. And we're taking our best estimate. It doesn't have that little symbol in the corner. Remember, this little symbol means 90 degrees. So we don't know exactly. It could be 89 degrees. It could be 91 degrees. But it is definitely close to a 90-degree angle. Okay, then you just learned on the previous page or wrote notes on angle pairs. There's a few groupings of angle pairs. We have the word adjacent angles, which just means that those angles are next to each other. We can't figure anything out by adjacent angles unless they're also complementary or also supplementary. Vertical angles are when angles are across from each other. They're equal to the same amount. So it has to be formed by like two straight lines. So if I make a line here and a line here, no matter what, this angle and this angle will always be the same. If they're not two straight lines, like if I have that line coming through, well, since this line has a bend in it, it's not true about like this angle and this angle. They have to be two lines that are straight. All right, then we come to this one here. And in this one, it looks like two angles together make 90 degrees. And from our previous page, we know that that's called complementary. You will need to know what that's called for your test. So this is called a complementary angle. And then we also need to know that complementary angles add up to 90 degrees, so we can figure out missing angles by taking what we're starting with. So this one starts with 90, and then subtracting what we have to see what we have left for the other angle. So I'm just going to do this in my head. I've got 49 degrees goes here. This next one is different. It is doubly as big as the previous one. Notice that this one makes a straight line when you put this angle and this angle together. It makes a straight line, and a straight line is 180 degrees. So we're going to take our 180 degrees, and we're going to subtract what we have on this side to find out what must be left over for the side that says A. And so I'm just going to subtract that, and I get 108 degrees. That goes here on this side, so that when I add those two up together, I get 180 degrees. Here are some triangle notes. Pause the video and copy down whatever notes you need. Remember, a triangle has two names. It has a side name and an angle name. It only has one side name and one angle name, so you have to be able to pick which one works. Okay, here are all my choices. These up above, these are all angle names, and then these are all side names. So we're just going to go through and talk about each one. So first, if I'm looking at the angles, I'm just going to do all of them for angles. If there are 3 acute angles, then it's acute. If there's only just one obtuse angle, then it's obtuse. You can never have more than one obtuse or one right in a triangle, or it wouldn't close. So if it has just one right angle, it is a right triangle. So looking here, I see the right angle symbol here and here, which means this will be a right angle and this will be a right triangle and a right triangle. These other two, I don't see any right angles. When I'm looking at this one, I see acute, acute, and acute. Remember, acute means 90 degrees or less. So this one's going to be an acute triangle. And then this one looks like acute, acute. And now I might want to do a paper test to see where's my perfect square corner. And it looks like it's bigger than that. So this one's obtuse. Moving on to my side lengths. If all of the sides are the same, that's an equilateral triangle. If 2 of the sides are the same, that's an isosceles triangle. If none of the sides are the same, that's scalene. These little symbols are telling me that this side and this side are the same, so I have 2 that are the same, which means isosceles. This one, it doesn't have any symbols, but I can tell that this side is longest, this side is next longest, and this side is the shortest. There, I can make my own symbols, which means none of them are the same, so it is scalene. Here we can see same, 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 or in other words, congruent, 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 which is equilateral. And this last one, you can tell that it looks like this one's the longest, this one's second longest, and this one's the shortest. I'm just showing that those are all different, which means it's another scalene. We learned by ripping the corners off of a triangle that all the angles in a triangle make a straight line, which is 180 degrees. So every triangle has 180 degrees. You can write that in your notes, but I would like you to memorize that. That is a good tool to have in your toolbox. So if I know that the total degrees inside of the angles of my triangle, so when I add up this angle, this angle, this angle, I need to get 180. I can go backwards to find a missing angle by starting with my 180 and subtracting the 2 pieces of information that I do have. Oh, how many degrees is this? That's right, it's a 90-degree angle. Okay, and when I subtract all that, I get 50 degrees left over for this angle here. Again, every time I have a triangle, I'm going to start with 180. I'm going to take away. So if I'm taking away 65, taking away 57, sometimes I like to do this, and I like to put these two together. So I have 122. That's a little bit easier if I'm trying to do mental math. 180 minus 122 is 58. So 58 degrees. Okay, and then this one, I've got 180, take away 130, take away 20. So I'm taking away 150, which leaves me with 30 degrees for this corner. Moving on. Here are some more notes that you can take. I don't think you need to write down the pictures for these, or for this one, I wouldn't call it an equilateral triangle, and this I would call it a quadrilateral, because it can be any 4-sided shape. Quadrilateral. But here's the information I would have. I would have that a 3-sided shape is called a triangle, and there's 180 degrees inside. That's what we just looked at. Then any quadrilateral, any 4-sided shape has 360 total degrees inside the shape. A pentagon is the name of a 5-sided shape, and that's 540. A hexagon, I think of hexagon and 6. They both have an X in them. The total is 720, and so on. Remember that if you were to not have this information written down, that we could figure out the amount of degrees in each one of these by doing this. We can start at any vertex, and we can draw lines to our other vertices. This forms the smallest amount of triangles possible. And we will always notice that, let's say this is a 7-sided shape, that there are going to be 2 less triangles than the number of sides. So if I take away 2, I get 5 triangles. Well, let's count. 1, 2, 3, 4, 5. There are 5 triangles. So what I'm going to do is I'm going to take my 5 triangles. I'm going to multiply that by 180 degrees in each triangle. This is why it's helpful to have that memorized. And I will get 900 total degrees. So these are completely figure outable. I could give you a 12-sided shape and you could figure it out. I will not give you one of those on this test, but just so you know, you could figure it out. You could even figure out a 100-sided shape without drawing it because you know that it's going to have 98 triangles, and then you can multiply that by 180. Okay, so knowing those pieces of information is helpful. So first I'm going to look at my shape and I'm going to count how many sides it has. So 1, 2, 3, 4, 5, 6 sides. A 6-sided shape is a hexagon. So we need to be able to name it hexagon. Then we need to find out how many total degrees are in a hexagon. I can look at my note sheet, or I can take 4 times 180 and get 720 degrees. I'm going to use my handy dandy calculator when I do this. And what I'm going to do is I'm going to start with 720 in my calculator. Then I'm going to subtract all of these angles that I have given to me, and that will give me left over the one that is for X. So I'm just going through 720 minus 135 minus 110 minus 120 minus 130 minus 100 equals 125 degrees. That's my missing angle measure. I want to make sure that that looks right. Well, it is an obtuse angle, and 125 degrees is obtuse, so it looks good to me. Okay, let's do the next one. So the next one is a 1, 2, 3, 4, 5-sided shape. A 5-sided shape is called a pentagon. Okay, my pentagon has 540 degrees. I could figure that out, or I could look at my chart. I'm going to take 540, I'm going to minus 90, because that stands for 90, minus another 90, minus 120, minus 107. So here I take out my calculator, 540 minus 90, minus 90, minus 120, minus 107, and I'm left with 133 degrees for my missing angle measure. It's obtuse, it looks correct. Moving on to the next one. The next one is a 1, 2, 3, 4, 5, 6, 7-sided shape. That's called a septagon, or I like to call it a heptagon, that both names are correct. A heptagon has 7 sides, so it has 5 triangles. So I forgot, so I just multiplied out 5 times 180, and I get 900 total degrees. And I'm going to start with my 900. I'm going to take away 130, take away 122, take away 130 again, and another 130, and 128, and 138. And I'm left with 122 degrees. Should be an obtuse angle. It is obtuse. It looks like it might be slightly smaller than that, but we're going to call it good because it's obtuse and it matches. Sometimes the numbers don't match up perfectly to what it's going to look like, but if you get an obtuse answer, your angle should be obtuse. If you get an acute answer, your angle should look acute. All right, there are area formulas on my board. I'm going to write the formula as I use them. I'm going to start with the parallelogram here because it's the easiest formula. So parallelograms, we saw in class that we could take this little chunk of it off and we could put it over here, and voila, now we have a rectangle. And we've always known, well, we haven't always known, but for a long time we've known the area of a rectangle is just length times width, or base times height. So we're going to take the base, which is 10, and the height, which is 4.9, and multiply them. That is 49. And since this one doesn't have any units, none of them do it, it looks like. I'm just going to call it units squared because my label should always be squared when I do area. Do not divide in half because we're using the entire thing for this formula. Okay, the next one, the next hardest one is probably your triangle. Okay, if we looked at in class, if we doubled our triangle, then voila, we made a rectangle again. So we could take our base times our height. 24 times 7, I'm doing that on my calculator, is 168. Okay, but I have 2 of them right now, and I don't want 2 triangles. I just want 1 triangle, so I have to divide it in half. So the area formula is base times height divided by 2. That's how you find the area of a triangle. This one was area equals base times height. Okay, so half of 168 is 84. 84, again, we're going to call it units squared. All right, and the last one is a trapezoid. This trapezoid, we need to find the bases and the height. That's the tricky part. So first, the bases are always parallel to each other. So we're first finding two sides that will never touch. Those are my bases. I'm going to add my bases together. So the formula is base 1 plus base 2. And since adding comes after multiplication, we have to put them in parentheses to say, do that first. Add them up first. Then we're going to multiply it times the height, and then we're going to divide it by 2. Well, why are we doing that? Well, if I had two of these lined up, let's see, I think it's like that, okay? I would have this 11 would be down here, the 17 would be up here, kind of flipped over and doubled. I would have a parallelogram. Or sometimes I would have a rectangle, depending. I think I might have, yeah, I don't know if I drew that correctly. I think I was supposed to draw it this way. Ignore that little line. Okay. And so what we did was we took this together to make a base, and then we're going to times it by this height, and then we need to divide it by 2 because we're basically finding the area of this whole thing plus the area of this whole thing. We only want one of them, so we got to divide it by 2. So what I'm going to do is I'm going to take 11 plus 17, which is 28, times my height, which is 8. Make sure that we're using the straight up and down height, not the slanty height, not this slanty height. Okay, and then dividing by 2. So 28 times 8 divided by 2 equals 112. Again, I don't have a label, so I'm just going to call it units squared. Last but not least, we're going to have a composite shape where we've fused two shapes together and we need to separate them out. So there's a couple ways I could look at this. I could look at it as drawing a line here and having this rectangle and this rectangle. Or I could draw it here and having this rectangle and this rectangle. I think I would like to do it that second way. So it doesn't really matter. You can do it whichever way you want. So the first step is I need to find the dimensions of my rectangle. So I'm going to call it the purple rectangle and the blue rectangle. So I've got my purple rectangle here. The base of my purple rectangle, because I know I need to find the base times the height if I want to find the whole thing, is 13. But the height isn't given here. Let's check this side. Not given here. But I do notice that this whole thing is 11 and this part of it is 4. So what's left over for this other part of it? This part right here. So if I have 4 plus what gives me the whole 11? Oh, did you say 7? Very good. Sorry, I was changing my pen colors. Okay, so I've got a base of 13 and a height of 7. And to find the area of a rectangle, I just multiply them out and I get an area of 91. I'm just going to leave it as 91 and I'll put my label on it at the end. Then the second rectangle, we're going to actually call it the green rectangle here since I used so much other colors on it. Okay, this green rectangle, I see that I have a height of 11, but my base is unknown. Well, if we look here, we can see that this is 18 and this part of it is 13. So what's left for this part down here? Did you say 5? You're right. So I'm going to take my base times my height, 5 times 11, and I get 55. So the area of the green rectangle is 55, and the area of the purple rectangle is 91. But now I want to know the area of both of them put together. So I'm going to add 91 plus 55, and I get 146. Since my label is centimeters, I'm going to call it centimeters squared. Area is always counting the amount of squares inside. Best of luck with your test. I hope everything goes well.